Hello folks, we are back with the next video of this exercise 6.1, and here we are now going to take up, already we finished the problem number 1 and problem number 2 in the previous video. Now we are going to take probably a couple of next problems. Right now at least we'll start with the problem number 3. Now in the problem number 3, very simple, no, nothing like what is going to come up or what we did in the earlier chapters. Is a very simple problems. What they tell. The problem number 3, they say that the radius of the circle is increasing uniformly at the rate of 3 centimeter per second. And the rate at which, find the rate at which the area of the circle is increasing when the radius is 10 centimeters. So let R be the radius of the circle and A be its area. So that's assumed. Okay, so with that we have we will therefore what's given now, let's try to list what all things are given. I think they give us dr by dt, they also give us r, and they ask us to find dA by dt. That's our question. So then in that case they have told us that dr by dt is 3 centimeter per second, and so that is 3 centimeter per second, and r is 10 centimeter. That's what is given to us. Yeah, they ask us to find the rate at which the area of the circle. So dA by dt is what you have to find. So obviously we have to start with the area of the circle. So we all know that since or let or whatever, since area is pi r squared, we all know it. For a circle it is pi r squared, as we did before. We'll find out because you're given with respect to t. So let's find out the derivative on both sides with respect to t. Then in that case, here you have dA by dt. Let's find out the derivative of pi r squared. Pi is a constant, so no derivative, and r squared with respect to r, the derivative is 2r. But since we are looking at derivative with respect to t, we have to account for it, so it becomes dr by dt. Now let's see what all things we have. We can substitute. So we have dA by dt at maybe r equal to 10 centimeters. We have certain things, so let's substitute. So it's 2 pi, r for us is 10, and dr by dt is 3. All these things we have substituted. So it is like 3 2s are 6 pi, 60 pi. Yeah, so it is 60 pi, and because it is dA by dt, it will be centimeters squared per second. So that's how it is. I hope that's what they have asked us. Yeah, they have asked us what is the area of the circle. Yeah, the area of the circle is 60 pi centimeters per squared, per centimeter square per second. There are very little chances that this can come in a bigger question. It can come for 1 mark, 2 mark, depending on how your paper comes up, like that. So that's how it is. That's about it. Once we are done with that, we can move to the next problem, problem number 4. Let's see what it says. Problem number 4 says that the edge of a variable cube is increasing at the rate of 3 centimeter per second. How fast is the volume increasing when the edge is 10 centimeters long? So let us have a cube whose side is x. Then we know that its volume is x cube. So this is like the background. Now we work with it. They give us certain things. They give us that the edge is increasing at the rate of. So let's write that. They give us that given that dx by dt, and they also give us the edge. Both these are given. They give us that the edge is increasing at the rate of 3 centimeter per second, and the edge, they say, is 10 centimeters long. About like this. I hope it has not got exchanged. Let me cross check. Yeah, how is it now? Exactly same like the previous one. All right. So that makes our work very easy. We know the volume. They have asked us to find out the rate of volume. We know the volume. Volume is always x cube for a cube. So therefore, you will find out the derivative with respect to t. Derivative of x cube with respect to x is 3x squared. Because it is with respect to t, we have to account for it. Now, after doing all that, we have the thing at x equal to 10, which we can get it substituted. 10 squared, and dx by dt for us it's 3, so that's like 900. 3 3s are 9, 10 squared is 100. So that's 900, and what unit is centimeters squared per second. quite like quite easy to attempt. So we can quickly move to the fifth problem also. What does it say? A stone is dropped into a quiet lake and waves move in circles at a speed of 5 centimeter per second. At the instant when the radius of the circular wave is 8 centimeter, how fast is the enclosed area increasing? Now I hope you are able to visualize. We can always, whenever in a pond we put a stone, we can see those circles. They keep on, and circles, how they are, there's not a single constant circle. It's not like that. The circle keeps on increasing. So that's exactly thing that has been put over here. So they tell us that anyhow, so it's a circle. So suppose we are considering a circle whose radius is r. We all know its area is going to be pi r squared. With this in background, we are going to do our work. What they tell us? They tell us that speed is 5 centimeter per second. So we all know that speed is rate of change of the displacement. So that way, in that case, the rate of change of distance. So therefore, in this case, it is going to be r. So therefore, let's put it across in this way. Given that dr, if r is the radius of the circle that is formed in the pond, then the speed that they tell us is 5 centimeter per second. All right. What else do they tell us? They tell us that you have to check the radius at 8 centimeter. If when radius is 8 centimeter, you have to find out how much the area, what is the rate of change of area at r equal to 8. That's the question. So again, we have to do the same thing. It's a circle. So you have to, area is what they are asking. So we have to go for the area. Area we all know is pi r squared. Rate of change of, it's very clear. So therefore, taking with respect to t on both sides, pi is a constant. Radius r squared, the derivative of r squared with respect to r is 2r, but then you have to account for the r because the derivative is with respect to t. Okay, that's it. Now they ask us to find this rate of change of area at the time when the radius is 8 centimeter. So we'll just substitute. Radius is 8 centimeter and the rate of change of the radius at that time, which they call it as speed, is 5. So that way, how does it come? 8 5s are 40, 80 pi. 80 pi centimeter square per second. That's it. Pretty simple problem. So even if they plan to ask, they cannot ask for a bigger mark. They can ask for only as short and very short questions. That's it. So that's about it. Of course, when it comes for for lesser marks, very short or short questions, we don't elaborate and write. You have to be very careful about the time that you devote for such questions. In fact, for short and very short questions, now also you have your MCQs. So therefore, those are the places where we really go stepless. Try to reduce your steps as much as possible. Maybe attack a single problem maybe in maybe say half a minute or even maybe 20 seconds or 30 seconds, so that you can keep up the time for the other problems. So there and all, you should not stick to the steps. Just quickly scribble and get the answer, and of course the correct answer, so that you can save on the time, and finally it helps you in solving the bigger problems where steps are necessary. Generally children, what they do is for MCQs they will sit and waste their time writing steps and all that, and later on where steps are required, where marks are reserved for the steps, they have no time to write it. So that should not be the case. So point being that these can come as MCQs. So in that case you should not plan to write all like this and all. Just probably take just the last step and quickly, as I said, not more than 20 seconds you should take to finish this, so that you can reserve that time for other things. Thank you. With more problems we can come in the next video.